HTTP is the fundamental part of microservices and web development. When working as a DevOps engineer, we often have to work with microservices and HTTP web applications. When learning how to code, especially as a DevOps engineer, you might come across HTTP or build a web application. Maybe you want to write your own web application to automate something. It's often very useful to have a web application with an HTTP endpoint. That's useful under many scenarios. In this video, we'll be building a Python application that deals with customer data. It will read and write customer records to a JSON file. Today we'll be adding a web server interface to our application, which allows us to get all customers, get a single customer, or update a single customer. In this episode of Learning the Python Programming Language, we're going to be building our own web server application. In our introduction to Python, we've covered all the basics and the fundamentals of Python, such as variables, for loops, if statements, and more. We've learned how to read and write and handle files. We've also taken a look at how to work with JSON and CSV data. If you need to recap on that, check the links down below. In this video, we'll be building a web server with 3 endpoints. The first endpoint is to get all our customers. The second endpoint is to get a single customer by its ID. And the third endpoint is to update a customer by passing in the ID and the record of the customer we want to update. We've got quite a bit to get through, so without further ado, let's go. So if you take a look at my GitHub repo, I have a Python folder, and in the Python folder, I have an introduction folder with the full introduction to Python in various parts. In the introduction folder, we have a README, which is the introduction to Python. This shows you how to run Python in Docker, talks about all the fundamentals of Python. Then in part 2, we also have a README, and that is all about working with files. In part 3, we take a look at dealing with JSON data, which is a very important data structure when dealing with microservices. In this video, which is part 4, we're going to be taking a look at HTTP. So in the part 4 HTTP folder, I have a README with the introduction to Python using HTTP Flask. So be sure to check out the link down below to the source code so you can follow along. So the same as every other series, we always start with a Docker file. So what I'm going to do in my part 4 folder, I'm going to create a new file called Docker file, and this Docker file will define our development environment. So we don't have Python running on our machine, we're going to need Python to write our code. So what we're going to do is take the snippet from my README, which is saying from Python, and sets a working directory. So I'm going to copy paste this into my Docker file. So you can see here we are starting with a Python base image, and this is using Python 3.9, and it's using an Alpine flavor, which is very lightweight. It's going to tag this layer as a dev target. This allows us to do multi-stage build, which we'll take a look at later. And then we're going to go ahead and define a working directory called /work. This is the folder we're going to be mounting in our source code. Now to build this container, it's really simple. The first thing I'm going to do is change directory to the Python introduction part 4 folder. Copy paste this to the terminal, change directory. This is where my Docker file is located. When I run ls, you can see my Docker file is over here. So how do we build that Docker file? Well, it's pretty simple. We say docker build. We want to build the dev target, which is the first stage and the only stage we currently have. We want to pass in dot because that's the location of the Docker file, which is the folder we're in. We're going to tag this image by saying -t, and I'm just going to call it Python. So I'm going to copy paste this to the terminal. This will go ahead and build up our container image. Now that we've built that container, it's very easy to get it up and running. We're going to say docker run -it because we want to run interactively, -v because we want to mount a volume. We're going to mount in the volume, which is defined by an environment variable called pwd, which is the current working directory. So we're going to mount this part 4 folder into the container because this is where our source code is going to live. We're going to mount it into the container on /work because that is the working directory we have defined over here. And we're going to call our image, which we've just built, which is called Python. And I'm going to say I want an sh shell terminal so that I can interactively work inside of the container. So I'm going to copy this line. I'm going to go ahead and paste it to the terminal. And now you can see we are inside of a container. To show you that we have Python, I can say Python -- version, and we can see we have Python running on this container. So now we have a development environment inside of a Docker container, so we can do all our coding and testing inside the container. This makes it extremely portable, especially when we're going to be building and shipping a container to production. It'll make sure that whatever we write and test is the same as what we ship to production. It also means that we don't have to worry about the different versions of Python that might behave differently between different machines. Docker helps make our application extremely portable. So now that we have a Docker container with a Python environment, we want to go ahead and build our application. We're going to be building the same application we did in part 1, 2, and 3, which is dealing with customer data. And then we'll put a web server in front of that application. So what I'm going to do, the first thing is I'd like to create a separate folder for holding my source code. So in my part 4 HTTP folder, I'm going to right click, create a new folder called src. This is the source folder that's going to hold all my Python source code. And to create my application, I'm going to create a new file inside here called app.py. This is the Python file for our application. So in part 1, 2, and 3, we spoke about dependencies. We're going to need a couple of built-in Python dependencies to work with our application, work with our data. The first one is os.path, because we're going to need to be reading files from the operating system, from the local disk. That's our customer file, our JSON file. We're going to be working with CSV. We might remove this later. And we'll be working with JSON, because our customer data is stored in JSON files. The next bit of code is we want to define what a customer looks like. So we've covered classes in our fundamentals and variables. So I have this snippet in my README file. I'm going to paste it to my app.py, and this is indicating a class customer, which defines what a customer looks like. It has various fields on it: customer ID, first name, and last name. It also has a function. In part 1, we've taken a look at functions, and it has a function to calculate the full name, which simply concatenates the first name, adds a space, and the last name. So this is the class that defines a customer. Next up, we're going to create the function that gets all the customers from a JSON file, converts them into classes, and returns them back to the caller. So I have this little snippet in my README, which I'm going to paste to my app.py. It's a function which we covered in part 1 called getCustomers. It takes no input. It uses the OS path import at the top here to check whether the customers.json file exists. And if it does exist, we covered if statements in part 1 as well. It's going to go and run the with statement, which opens the file and creates a variable called customer file to read that data. So it says customer file.read, reads all the contents into a variable called data, and then uses the JSON library that we imported at the top here to load that data. So we load it into a JSON structure and return it to the caller. Now, if that customer.json file does not exist, we simply return an empty dictionary. In part 3, we've taken a look at how to work with JSON, and we know that when we read data from a file and load it into JSON, JSON is basically a dictionary in Python. So this will return back a dictionary of customers, and this returns an empty dictionary if the customer file does not exist. So this will return all the customers in that file. Now, what if we're only interested in returning one customer, like a specific one? So to do that, we're going to need another function called getCustomer. So what I'm going to do is define this small function in our app.py on a new line called getCustomer, and that one takes in a customer ID. So the way this function will work is internally it calls the getCustomers function that we defined up here. It'll get all the customers back, and because that is a dictionary that it gets back, dictionaries have keys that we can access the values with inside of the dictionary. So to access the customer value, we're going to access our dictionary that we've returned from the getCustomers, and we're going to access that dictionary by passing in the key called customer ID that we got from the input parameter of this function, and we're going to return the value of that dictionary item, which is the customer. So now we have a function that gets all customers and one that gets a single customer. So how do we update all our customers? Well, to do that, we're going to create a new function called update customers, which takes in a dictionary of customers and writes it back to file. So for that, I have a function in my README over here. We're going to go ahead and paste that in our app.py, and that is an update customers function, which takes in customers, and this is the same type of object that our getCustomer function returns, which is basically a dictionary of customers. And to update it, what it's going to do is it's going to use the with statement to open up our customers.json file, and it's simply going to take in all the customers. It's going to convert the customers dictionary into a JSON string with the JSON dumps function, which we've taken a look at in part 3. Once it has the JSON data, it's going to write it to the file using the file.write function. So this will take in the dictionary of customers and just simply update the file. So now that we have some basic functions to start with, we have get customers, get customer, and update customers. So what I'm going to do is in my part 4 HTTP folder, I'm going to create a new file called customers.json, and that's going to hold all my customers. And then in our README, we have an example of what that file will look like. So I'm going to go ahead and grab this content in my README, paste it into the file, and you can see we have a bunch of our legendary engineer customers defined in this customers.json file. So the file has all the metadata of the customer. It has the key, which is the customer ID. And then it has the customer ID, the first name, and the last name. So now that we have our customer data, we can go ahead and test this logic by getting all the customers, adding an extra customer, and writing it back to the file. So on a new line here, what I'm going to do is I'm going to return all my customers by saying customers equals get customers. I'm going to call the get customers function that's going to read all the customer data into this customers object and print it to the screen. Now to test this, I can run the Python script by saying Python src/app.py, which is the path to the file. I can press enter and this will run our code, which you can see clearly here. It's got our JSON file and it's returned our customers to the screen. Now to test the update customers function, it's very simple. I'm going to create a new customer by using my class. So I'm going to say customers access a new key. So this is customer ID H, and I'm going to assign a new customer from our class. I'm going to define our class here by passing in a customer ID, a first name, and a last name, and then using the internal dictionary property to assign the dictionary back to our customers dictionary. And then what I'm going to go ahead and do is call our update customers function, pass in that full dictionary of customers, which will include the new record. I go ahead and run that, and now if we take a look at our customers file, we can select all, we can format the selection, and we can see we have our new customer added. So now we've recapped on some of the fundamentals of Python. We've built a small application that's able to read and write customer data to file. Now to allow clients to execute our functions and update our customer records, we're going to need to run our application behind a web server. Now many programming languages come built in with a web server. Other programming languages allow you to bring your own web server by using an external library. There are many flavors of web servers available. In this video, we're going to be taking a look at a popular web server called Flask. So Flask is really well documented, very easy to follow, and it's a very popular web server for Python. They have a quick start guide that shows you how to run a minimal application. You can see only a few lines of code to get a web server up and running. Now you can see this starts from an import statement. So you can see similarly to how we've imported standard libraries, they import here from Flask, import Flask. And this is something we've not covered in the past before, because in our previous videos, we've been taking a look at internal libraries that comes with Python. Flask is an external library which does not come with Python. We can't simply import it. So this brings me to my next introduction to a thing called pip, which is a package installer for Python. If you're familiar with other programming languages, every programming language needs some form of package manager to bring in external libraries. In our Go series, we use GoGet, .NET uses NuGet, Node.js uses NPM, Python uses pip. Now, if we search on the pip website, we can find all sorts of external packages. One example is Flask, and it always brings up the latest version. So you can see here says Flask 2.0.2, and to install it we can simply say pip install Flask. So what I can do is I can copy this to the terminal here. I can say pip install Flask. That'll go ahead and install Flask and we're done. Now my script can import Flask and it will just work. We can also pass a version to the pip install, which is a slightly better way of doing it. Remember, when you're building microservices, you don't always want to build the latest version of Flask. You might want to pin it to a specific version that has long-term support, because if I build this application today, it might be using 2.0.2, but my build server might build it a few days later and they might have version 3, which means my build server will build something that is very different to what I'm testing locally. So it's very important to always pin the latest version. Also, we don't want to remember how many pip install commands we want to run. So in our Docker file, we can either write new lines to say pip install Flask, pip install something else, but that becomes harder to maintain. Python has a built-in file called requirements.txt, or any arbitrary text file where we can define what libraries we want to install. So I talk about this in my README, but let's go ahead and go to the Python introduction part 4 folder, right click, create a new file called requirements.txt. That'll create a new text file, and in here we can define our dependencies. And normally what you do is you define every line a new library. So we can say we want to pull in Flask, and then you pass in double equals and the version you want to pull. So what we can do is we can go with Python 2.0.2 because that's the latest one at the time of this demo. And now instead of saying pip install Flask and running a pip install for every dependency, we can simply say pip install -r and point it to a text file. So it'll look like this. I can just say pip install -r and we're going to point it to our source requirement txt. So the other thing I just need to do is move this file into my source folder. I'm going to go ahead and move that so that it lines up with my directory here. I'm going to go ahead and run that. And we can see we've already installed it, but this shows you how to manage your dependencies slightly better. So now that we have the Flask dependency installed, let's go ahead and build a minimal web server and get it up and running. So to do that, it's very simple. We can either go ahead and grab this minimal application from the Flask website, or I also have it in my README. We can go ahead and grab that. We're going to go to our app.py, go down to the bottom. Let's remove this test logic that we created earlier. So we only have our import statements, we have our customer class, and we have our 3 functions. Let's go ahead and paste that application. And what I'm going to do just to neaten this up, I'm going to take this from statement. I'm just going to move it, and I'm going to move it all the way to the top here. This is our application. So you define a Flask app by saying app equals Flask function and pass in the name. And you go ahead and define routes. So you can see here we've used that app variable to define a route called /. So this is the root of our web server. And whenever this endpoint gets triggered, Flask will automatically call our hello world function and returns some data as a response. So here we're returning a paragraph HTML object, and we just pass in hello world. Now to start up our application, it's a little bit different than running the Python script. Before, we simply ran a Python command to run our script. To start Flask, it's a little bit different. What we're going to need to do is export a Flask app environment variable. So this tells Flask where our app.py is. So we're just going to say Flask app equals source src/app. That is the location of our application. And then what we're going to do is call the Flask run command. So we say Flask run. We define the address where we want to bind to. Since we're running in a container, it's going to be 0.0.0. And then we pass in the port number. So we're going to expose our application on port 5000. So I go ahead and run this, and we can see now our application has paused because it is running as a web server, so it's waiting for requests to come in. So now you should note that you can access the application on HTTP localhost 5000. If I go ahead and copy this and I open a new browser tab, notice that it's just simply hanging. Site cannot be reached. This is because our application is running in Docker and we have to go and expose that port. Port exposure is very important when working with Docker containers. So to expose that port, I'm going to press Ctrl+C C to break out of my application. I'm going to type exit to go outside of the container again. And I'm going to rerun my container by saying docker run -it, the same way I did before, but this time I'm exposing a port with the -p flag. I want to expose 5000 on my machine, and I want to bind it to 5000 in the container. And then I want to mount my volume for my code and call my Python container with a shell terminal. Now remember, we have the container up and running. There's no dependencies. So we're going to have to go again and run pip install, but this time we'll point it to requirements.txt instead. So you can see it's gone ahead and looked at our text file, detected it needed Flask, and installed it. Then I'm going to go ahead and expose my environment variable as I did before, and I'm going to run my application saying Flask run. And now our app is up and running. And notice if I refresh this page, now we get the content hello world. So we've accessed the root route on this application, which hits our hello world function as defined in here. Now currently we have one endpoint at the root of our web server. Now to create multiple endpoints for our HTTP server, we need to define what's called routes. Currently we only have a single route. We would like to have 3 routes. A route is a URL path to an endpoint of our application, which will trigger a given function. If a client calls an endpoint that doesn't have a route defined, we'll get a 404 status code, which means not found. It's very important as a web developer to learn about HTTP status codes, as it's useful to troubleshoot web applications. In this example, we're going to have a route called /, which is the root of our application that returns all customers. Then we're going to have a route called /get, which returns a single customer where the client can pass the customer ID over the URL. And finally, we're going to have an endpoint called /add, where a client can pass in a customer to update it. So as shown in the documentation, it's very simple to add routes to our application. As we've done before, we created a route called /, which is the root of our app, which calls a function. This way we can map multiple functions to different routes. Here we have a route called /hello, which calls a function hello and returns hello world. So we can define multiple routes. We can have a route to return all customers, get a single customer, and update customers. If we take a look at variable rules allows us to pass in URL parameters. So here we can have a route called /user and a username behind that. So if someone does a get call on /user with a username, it will pass the username as a variable to this function. This allows us to pass input. So let's go ahead and define our routes. So currently we defined our Flask name. We have a route here called /. I'm going to go ahead and remove this. And if you take a look at my README, we have 3 routes defined. I'm going to go ahead and copy paste them to my app.py file and take a look at what we're doing. We're exposing 3 routes. One is called /, which by default is the root of our application. It's going to call the get customers function. And notice this is not the get customers function we defined up here. This one has an underscore in here. So I like to keep these functions separate, as these are going to be our web handlers. These functions can internally call our other functions that we've defined before. So we have an app route to get all customers. We have another route, which is a get endpoint, which is going to use the variables I shown earlier as a URL parameter. So here we tell Flask that we want a string called customer ID. So we can put a type here followed by the name of the variable. And then we'll talk about methods in a minute. So this will call the get customer function, pass in the customer ID. And then we'll have another one called /add, which allows a client to post customer details to our Flask application, and that detail will come to the function as an input parameter. When we develop web applications, it's very important to understand HTTP methods. Methods define how an endpoint is called. Sometimes we simply want to retrieve some data. Other times we may want to retrieve data but pass in input like a customer ID. Other times we might want to call an endpoint but submit complicated data like JSON data. So in our example, we may want to just call an endpoint to get all customers. In this case, we'll use a get method. Or we may want to get a single customer by passing a URL parameter like a customer ID. This will also be using a get method. To update a customer, we're going to have to pass the customer object to an endpoint. Usually when you send data over the network, you use a post method. So to explicitly tell Flask about methods for each endpoint, you can see here on the default route, I have no method. By default, Flask will use get. So this will use a get method. Or we can explicitly say get by passing in a parameter to the route function called method. So I pass this in, and this is an array of strings. So I can say I want to be using get method here, or you can use comma and post and pass in multiple types of methods. So for returning a customer as well as returning customers, we're going to be using get methods. To send data to our add endpoint, we're going to use a post method. Now, if we take a look at our web server logs that we're running in our Docker terminal, we can see the logs for the get endpoint. If I hit refresh here a couple of times, you can see that we see multiple get calls. So they are get requests to the root endpoint. And you can see we're getting an HTTP 200 status code, which means success. Look what happens when I try to access the add endpoint. It comes back as not found. And you can see here's a 404. 404 means not found because the route is not defined. This is because we need to restart our application because we've changed our Python file to add the new endpoints. So I'm going to go ahead and press Ctrl C, and I'm going to rerun my application by running Flask run. And if we go back to our application and we refresh, notice now we get method not allowed. This is because by default the browser uses a get. So it's passing get here. We can see in the logs we got get/add. And our application only allows post. So we get a 405. 405 means method not allowed. If we take a look at our route for add, we're only accepting methods post. So this is a good way to restrict clients to only call certain endpoints with certain types of methods. If you want to update data, you use a post or a patch. And if you want to get data, you use a get. So now also you can see if I go back to the root path, we can see we're now triggering the hello get customers function. And if I go /get/a, we're calling the get function. And this is the customer ID. So let's go ahead now and plug in our customer functionality. So filling out our routes with our business logic is very, very simple. But we're simply going to call our get customer function and perform the actions. So one update I'm going to make here is explicitly say I want to serve get methods here. And then what I'm going to do is I'm going to remove this HTML we're returning. And I'm going to say I want to get the customers. So I'm going to call my get customers function we did earlier, and that'll return a dictionary of customers. Now to return that to the client, generally clients accept JSON responses and APIs generally work with JSON. So I want to convert this customers dictionary to JSON using the JSON dumps function. That's very simple. I just say return JSON.dumps, pass in the dictionary. This will return JSON back to the calling client. Now the next route is very simple. So Flask will automatically handle the customer ID and pass it into the function over here. So what we want to do is use our get customer function and return that customer. So I'm going to say get customer, pass in the customer ID, which gets a customer back, and simply go ahead and return it. So that is our two endpoints, one to get a customer and the other one to get all customers. So let's test that by breaking out of our application, rerunning our Flask app. And if we go to the browser now and we refresh it, we can see we're now getting customer with ID A. If we do get and the customer ID. If I change to the root path, we can see we return all customers as a JSON data. So we can get all customers and a single customer. Now, as a DevOps engineer, HTTP status codes are very important to understand because they let us know what happened to the HTTP traffic. Did the server receive the traffic? Did it reject it? Did it accept it? Now, a 200 status code means success. The 300 range status code like 301 or 302 is generally related to redirects. The 400 ranges are very specific, like 400 can be a bad request. That means our application does not understand the input. A 401 which can be unauthorized, 403 is forbidden, 405 is method not allowed, and more importantly 500 status code, which means there's an internal error in our application. Like let's say we couldn't read the file for some reason. That's an error that our application is not handling. And normally when we get a 500 error, we would check the logs of our application to see why it crashed. So let's take a look at an example of troubleshooting our application. So here you can see I'm calling the get call and I'm passing in a customer ID with Z. Now I know that this customer ID doesn't exist. So technically here, we should be getting something like a 404 not found, saying the customer is not found. But instead, we're getting internal server error. If we take a look here, we can see the server got a GET. It responded with 500. Now, when an internal server error occurs, we need to go and take a closer look at the logs, because that means our application is not handling a specific scenario. So if we take a look at our logs a little bit closer, we can see that we're getting a key error Z on line 25. So on line 25, we can see we're accessing a customer in the customer's dictionary by passing in an ID that doesn't exist. So we'll need to go ahead and fix this error firstly, and secondly, return the correct status code. So let's go ahead and handle that error to check first if the customer exists in the dictionary and return the appropriate record. So what we do here in the getCustomer function, we call the getCustomers, we get a dictionary back, and then we're going to do a simple check. We're first going to say if customer ID in customers, which does a check to make sure that customer ID exists in the dictionary. If it does exist, we're going to go ahead and return it. So we're going to return the same line we did before. And then we need to handle the else case. What if the customer doesn't exist? Well, in that case, we're going to return a blank dictionary object. So now when we call this function with a customer that doesn't exist, we'll get a blank object back. You can also return something like a null value. So what I can do now in my handler, I can go ahead and get the customer back and then do a simple check to say if the customer is an empty dictionary, go ahead and return blank to the client with a status 404. And then I can handle the else by saying else return the actual customer. So this will go ahead and handle that scenario. So if I break out of my application and rerun it, and I go ahead and refresh this, we can now see we get a blank customer back. We don't get any data. Now, to troubleshoot web applications, it helps to open up the developer tools, which in Chrome you can open using F12, which opens the developer tools. You can see the network tab over here. And what I'm going to do is I'm going to refresh my page. We can expand the network tab and see that we got a 404 status. This is useful in troubleshooting web requests. Now, so far in this video, we've taken a look at GET requests, which is simple ways of getting data from a web server. Now, POST requests are a little bit more complicated because they accept data. Sometimes it requires our application to do validation to make sure the data we're getting is in the right format. So either the data is in JSON format, or if we're expecting a number or a string or a date, we might have to validate it. Now, when accessing POST data, we have to access what's called the web request, and we have to use the web request to access the body. Web requests have two components, the request body and the request header. Let's learn about it by handling our POST request for adding customers. So to go ahead and add a customer, we need to access the request body to access the data that the client sends to us. In order to do that, we need to go and add another import. So from Flask, we're going to import the request module. So at the top here, I'm just going to go ahead and paste that over there. So this will give us the request module. Now, to read the request body as JSON, it's very simple. What we can do, instead of returning hello, we can say print request.json. That'll print the request JSON to the screen so we can see it. And then what we can do is we can just go ahead as a test and return success to the customer and say 200 status code to accept it. So to test that, what I'm going to do in another terminal, I'm going to say docker run -it, and I'm going to run a container on my host network called Alpine, just so that I can access curl. I'm going to say apk add curl. That'll install curl in this Alpine container that I'm running locally. And what I'm going to do firstly is just stop our web server and go ahead and start it back up again, so it will reflect all the changes. And then in our Alpine container, I'm just going to run curl. So what I'm going to do here is I'm going to say curl. I'm going to post some data to that local host 5000 add endpoint that we created now. And then I'm going to pass some data to it by saying -d and passing data. You can also use utilities like Postman or any other utility to make a post request. Now notice when I run this command, what we'll see is a success. So we're getting this success that is being returned by the web server. Also notice that I've removed the customer from here, so I'm not passing in any customer. To get the customer, we have to look at the request JSON, which is the body of the request, which will be this payload over here that we're passing using curl. If I go back to my web server logs, we can see that it's returned none. So when we print out this request JSON, we're seeing none in the terminal. This is because Flask by default, when accessing request JSON, will only accept content type of JSON. So we need to set that in our request header. Setting a header is very simple in whatever utility you use to make a web request. If I'm using curl, all I need to do is pass -h, set the content type header to application JSON. This means our application will only ever accept JSON data, and then call the add endpoint and pass in a payload. So I'm going to go ahead and copy this, paste it to the terminal, and we can see success. And if we jump back to the web server logs, we now see that we're getting the payload. So we can see our payload exists in the request.json field. So this allows us to send a customer data over to the endpoint as well. We can say curl post. I can say -v to get more details from the response. I can say pass in content type JSON, call the add endpoint. This time I can pass in a customer ID, first name and last name. So I go ahead and copy this, paste it to the terminal, and now we can see it's been sent successfully. HTTP 200 is okay. But look at what happens if I break the JSON structure. So let's say we remove a comma from the JSON to make it invalid. If I go ahead and paste it to the terminal now, we can see now we're getting a 400 bad request. That is because we're taking advantage of Flask's internal JSON parser because we only accept JSON content type. Now, because we're receiving any type of JSON object, we need to go ahead and validate it to ensure we have all the fields of a customer. So to do that, what I'm going to do is I'm going to grab the JSON data from the request, and then I'm going to test the JSON data to make sure there's a customer ID, a first name, and a last name. That's very simple. What I do is I say if customer ID not in JSON data, return customer ID required with a 400 bad request status code. And then I'm going to do the same for first name, and I'm going to do the same for last name. This will ensure that if anyone posts data, they post those 3 fields, which are mandatory. And then what I'm going to do, now that I know my fields are populated, I can go ahead and get all my customers by saying customers equals get customers. I can now create a new customer object using our customer class, and that's very simple. I'm going to create a new customers in our dictionary, and I'm going to pass in the JSON data customer ID. So this is the data that was posted to us, and set that as a new key. And then what I'm going to do is define a new customer using our customer class. So I say customer open close brackets, and then inside I pass in the customer ID from the JSON data we got posted to. So I set the customer ID, I set the first name, and I set the last name. And now that I have created this new customer, I'm going to go ahead and call the update customers function and write it back to file. And finally, what I want to do is return success with a status code 200, letting the client know that the customer was updated successfully. Now, before we go ahead and test our add endpoint to make sure it works, let's go ahead and put all of this stuff together and build a production grade container image that we can run in production. Currently, we only have a 2-line Docker file, which is defining our Python development environment. Let's go ahead and build up a full Docker file where we copy in our source code, and we can build that container and mount in our customer's file. In a future video, we'll take a look at how do we scale our application. Having multiple Docker containers pointing to the same file can ultimately corrupt that file. It's not a good design. In modern web applications, we use something called a database. We can use something like Mongo, MySQL, Postgres, Redis, and more. This will help keep our applications scalable as well as stateless, as all the data will live inside of a database. So before we build up a Docker container, it's important to note that we're going to need to mount our customer file in. That means we'd like to move our data to a different folder than where our source code is. Currently, our customer's file is too close to our source code, and the application is simply looking for the customer's JSON file in the working directory. So let's go ahead and change that by defaulting the location to another directory. And in this example, I'm just going to say /data. So we're going to tell Python to look at the /data directory instead, where we can put all our data. This means inside of the container, container, our code will be in one folder and the data will be in another folder. Now let's expand our Docker file. Now instead of having two Docker files, one for development and one for production, it's better to use Docker multi-stage. So this is our dev layer, and we're going to be using these two lines to do development and debugging like we've done today. To create a production layer, what we're going to do is start a new from statement from dev as runtime. We're going to call our working directory /app in this case. Then what I'm going to do is I'm going to copy our requirements.txt into /app, and I'm going to run pip install -r and point it to the requirements text file I copied in the container. This means if we keep changing our source code, we're only going to be running pip install once because Docker will cache this layer. Once we've run pip install, installed all our dependencies, we're going to say copy /, and I'm going to copy my app.py into my app folder. Then to run the app, we need to set the environment variable telling Flask where our application is, and the Flask app is app.py, and because we've set a working directory to /app, we don't have to set the full path. And then the last line in the Docker file is going to be command and run the Flask server command. Now to build this application, it's very simple. All I'm going to do is break out of my development container. I'm going to quickly exit out of that, make sure we're in the part 4 folder, and we're going to go ahead and build a container saying docker build dot, that's where the Docker file is, -t, and this time I'm going to tag it as customer app. Note that I don't pass in a target here because we're going to build the entire Docker file. If you want to debug, you have to pass in target dev just like we did before. Go ahead and run that. That'll build up the full container we can run in production. Now to finally run the application, all we're going to do is say docker run -it, and this time we're passing in port 5000 again because we need to run a web. We're going to say docker run -it. We're going to expose port 5000 because that's what our application is listening on. We're going to mount in a volume. This time we're mounting in the local directory, and the purpose of that is to mount this customers.json file into /data, and we're going to call the customer app container image. We go ahead and run that, and notice now it is running and ready to go. And to test this out, I'm going to go ahead and run my curl command again. This time I'm going to add customer ID I'm going to add Bob Smith. So I'm going to go ahead and curl, paste that to the terminal, and we can see we got 200 OK back. If I go to my customer.json file, I go ahead and format the document, and we can see now it's added customer ID. So it's added our new customer. So now we have a web application with 3 endpoints. Now it's important to note that this is just the fundamentals of HTTP. There are a ton more things to learn about HTTP, such as how to get a TLS connection, how to do authentication for APIs you don't want anyone to be able to access, how to do good API validation, as well as versioning to ensure that if we change the structure of our customer, we don't affect all the clients that might be connected. Hopefully this is a good starting point to teach you how to write Python and deal with web applications. As I said earlier, in a future video we'll be taking a look at how do we store our customers in a database. So let me know down in the comments below what sort of videos you'd like to see in the future. And if you liked the video, be sure to like and subscribe and hit the bell. You can also support the channel even further by checking the Patreon link below or becoming a YouTube member. And as always, thanks for watching, and until next time, peace.